How to graph y equals x squared. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. We'll start with a grid. We encourage you to make a table, and we will use these 7 values to start. Please press pause and complete the table. So here are the values that you should have obtained. And notice when you square the negative numbers, they are positive as well. So let's go ahead and plot the points. So 3 squared is 9, 2 squared is 4, 1 squared is 1, and of course 0 squared is 0. And when we square the negatives, we get positives. So do you notice a pattern here in either the table or the graph? Press pause as needed. Well, here are some hints. So this is called, wait for it, symmetry in the table and in the graph. And there's symmetry about the y-axis, or the line x equals 0. Now, is this a V-looking shape? Well, to investigate that, let's try 2 more values for x. Between 0 and 1 is a half, and on the other side's negative a half. So we'll go ahead and square 1/2. And remember, 1/2 times 1/2 is a fourth, not equal to 1 like some of you think. That's what you're adding them. And if you square the negative 1/2, you'll also get a positive 1/4. So plotting those points over a half and up a quarter of the way, and over negative a half and up a quarter of the way. So the shape is not really a V, it's more like a U shape. So we'll connect the dots, connect the points I should say, and there we go, y equals x squared, called a parabola. The shape is called a parabola. Some terminology on a parabola. The vertex is a key point. In this case, it's at 0, 0. We have this line here that looks like a mirror line, but the phrase we're going to be using is called the axis of symmetry. And you'll notice the symmetry right here, showing points on either side equidistant from the mirror, but in opposite directions. So now let's look at how you would graph this. We're using what we call the parabola dance to kind of give you a feel for what that would mean. So we'll start with the vertex. And from there, we will go right 1, up 1, because when you square 1, you get 1. We'll go right 2 and up 4, because when you square 2, you get 4. And right 3, up 9, 3 squared is 9. On the other side, left 1, up 1, negative 1, the quantity squared is 1, negative 2, the quantity squared is 4, and the number negative 3 squared is 9. Connect the points. We get this beautiful looking parabola. Again, make sure it's more rounded along the bottom. Remember that 1/2 and a quarter, what we did before. And again, notice the symmetry about the y-axis. So we should also look at the domain and range of this function. So here we have the graph and the table. You can see the x values are here. We can only show 5 points, and here are the y values. So for the domain, we'll kind of look at it graphically, and it looks like all the x values have y values above them, okay, even though this kind of keeps going out. So the domain seems to be all real numbers. And we write that with that fancy script R symbol, meaning all real numbers. The range, well, you'll notice in here, doesn't look like we have any negative numbers here. So it's going to include 0 because of the vertex, and then everything above it. So it's going to be all real numbers greater than or equal to 0. And we write that in set notation as the set of all x such that set of all y, such that y is a member of the real numbers and y is greater than or equal to 0. Where can you see parabolas in the world? Anybody recognize this? Well, first of all, you do see the parabolas. So this is at the World War II Memorial in Washington, D.C. We encourage you to interact with another video in this series.